So my name is Dylan, and I'm going to be talking about a tool that I published about a year and a half ago that I've been slowly iterating on for the past year and a half, called TruffleHog. So the objective of TruffleHog is to identify secrets in source code. So before we jump into how that works, I just want to cover the basics of why secrets in source code are bad. I mean, first and foremost, they can lead to breaches, and I think we're all familiar with a couple notable examples, but I'll go over a few. They can also greatly aid in lateral movement. So you can imagine one particular computer in the environment being compromised that has access to source code, and if your bad guy has access to that source code, then they can gain credentials and then move to the hosts that your source code has access to. And along that same line, it can help elevate privilege as well. They can jump from one environment to another. One of the things that's tricky with this is exploitation of this is sometimes hard to detect. And the reason is because you're often using the secrets in the way that they were intended to be used. That's not to say you can't write detection, but it's a lot more difficult than, say, an exploit that you can fingerprint. Another example is workstations that get lost that may have secrets in them. And in general, source code is just very leaky. You can imagine scenarios where the .git directory is accidentally exposed, or scenarios where developers maybe copy-paste things over to paste bin. So source code can often end up leaking out in unexpected ways. So I have a couple of tragic examples here. One of which is one where Reed, one of the B-Sides organizers, had an AWS token in his personal GitHub account that a researcher found and reported to HackerOne, and Reed was kind enough to make this open so that everybody can see the vulnerability, and he paid $2K for it. So this is one of the lesser impactful vulnerabilities. But here, ramping up the impact a little bit, there was a researcher who crawled GitHub looking for Slack access tokens, and he found thousands of them, some of which went to high-profile companies. So you can imagine a bad guy taking advantage of this and squatting inside of your Slack. And then this is another example where a different bad guy went to GitHub and crawled a bunch of AWS keys in 2015 and found them, and an individual incurred a bill of over $2,000 because the bad guy used it for Bitcoin mining. And then last, the example that is probably fresh in mind for everybody here, the recent Uber breach where 57 million user accounts were exposed to a researcher because, again, a credential was put in GitHub and the researcher was able to off with the credential and gain access to the 57 million user accounts. So secrets in source code are bad. Now that we're all on the same page with regards to that, this is not a talk telling you how to manage your secrets or which secrets management solution to use. There's tons of them out there. I have a couple examples up on the board. You should do a lot of research and figure out the one that makes the most sense for your environment. TruffleHog is a tool that is intended to get the secrets from your source code into your secret solution. So there's a border collie up there, that's TruffleHog, and then the secrets are being herded into the secret solution. So where does source code live? It sounds like an intuitive question. You may immediately say it lives in Git, but the reality is source code actually lives in a bunch of places, and the more you think about it, the more places you end up finding. So version control is on the top of the list, but also source code lives in package managers, and source code lives in mobile applications. When you download a mobile app, you download the source code that runs on your mobile app, and that source code can have secrets in it. There was actually a talk on that earlier today. Slack, another common place that source code gets pasted into. Websites, when you render a website, you're rendering a bunch of source code, and secrets can show up in that HTML. But I'm going to spend a lot of time actually talking about this last bullet here, and that's revision history. So not necessarily the current version of your source code, but a version that is still accessible through your version control. So I have an example here of a sample repository that I'm sure most people have heard of, React from Facebook. And you can see the green on the top there is code that was added over time, and the red on the bottom there was code that was taken away. So this repository isn't special. It's pretty normal in this regard. But the point I'm trying to make here is that as much, if not more, of the source code was actually removed from the project, but still lives in the old version control. So there's more source code, or as much source code, that lives in the past as there does in the current revision of the code. And this is a problem when you imagine all of that past code potentially still having keys and secrets that are alive. So why is it that sometimes these things end up in the old version of the code? Well, simply put, I don't know if anybody in this room falls into this category, but at least at one point in time in my career when I was a developer, I may have pushed a secret and then thought the best way to handle that mistake was to commit over the top of it. So here, there's a list of commits that you can search on GitHub for the string removed password, and you can find thousands of examples of developers that committed passwords and then committed over the top of them rather than removing the commit. Another example here is maybe an entire feature is removed. So you can imagine if you're working in AWS, maybe first you think that S3 is a good solution for temporarily storing some data, and then later you change to SQS, and so you end up removing a big section of the code. You put a new credential in for the new use case, and the old credential may actually stay in the old buried version of the code that's still in your version control. And then the last example here, typically in a large company, when you submit a project to get open sourced, there's a security review process that it undergoes. And prior to that security review process, there's a good chance that your developers are going to want to try to clean the code up a little bit because they know it's not in perfect state and they don't want a lot of back and forth from the security team. And so if they have secrets in their source code, there's a good chance that they're going to try to clean that up. And one of the ways to do that is to commit over top of it. And I'll be willing to bet, in a lot of cases, when the pen tester or the security engineer gets a chance to look through that source code, they're only looking at the latest revision. I personally would never go through all the old revision history manually if I were doing a code review for a security audit for an open source review. So I have an example repository here. I cleared this with someone at Netflix, so it's okay for me to put this up here. But it's an example of an old AWS key that was committed to a public GitHub that was committed over the top. So you can see here from the minus in the red that this was removed from the project in an early incarnation of it, but the secret still remains. Now this secret is no longer live, if you're wondering, but this could just as easily be a live secret, and there were other cases where I identified secrets committed over in a similar fashion that were still live. So we need a way to scan these old commits. No one, like I mentioned before, is going through the negative code contributions, and grep doesn't find these. The way Git stores its blobs, grep doesn't identify them. They're stored in some binary content that I haven't really explored fully, but I know if you just grep for some anti-patterns, you won't be able to find them in the .git directory. So this was really the thinking and the reasoning behind why I made TruffleHog. And the intent of TruffleHog is specifically to go through the old revisions of the source code, all the branches, all the old commits, and help identify secrets that were potentially buried. But it also looks through the latest incarnation as well. So it's open source. You can find it on my GitHub. It's specifically pinned to Git version control. So if you're thinking of using this for SVN, you're going to have to convert it to Git first. It digs all the way back in time, and it finds secrets. So when I originally wrote this tool, I was set with a problem of how to identify these secrets. And the path of least resistance for me at the time was to just look for high sources of entropy. So what that means is if I saw a bunch of characters all together that were random and there wasn't any consecutive order to it, I would flag that and identify it as a likely secret. So here you can see the same commit that we saw before, and the AWS secret key is flagged as a problem. And if you'll notice, the AWS access key also looks pretty random, but that wasn't flagged And the reason is because this method isn't perfect. It has a lot of limitations. And one of them is the character set is something that I had to predefine. And so I said, look for random sources of entropy in base64 character set, and AWS access IDs don't fit that. So this method has some limitations. On the plus side, it's pretty good for pen testers. If you're pen testing an application, you can reasonably go through all the false positives. Good for an open source review for the same reason. You've got time to go through all the results and find some interesting things. And it's pretty good for bug bounty as well, because you've got all the time in the world and a whole bunch of researchers. With enough time, they'll be able to triage all the false positives. But the big downside to this method is it doesn't do well with the DevSecOps model, and it doesn't scale well. So in the same repository that I showed before on this slide, there were a bunch of false positives, and this is an example of one. The developer had basically committed a URL that contained a bunch of entropy in it, and TruffleHog flagged on it. So to combat this problem, to fit the DevSecOps model more, to put this into the DevOps pipeline and deliver results more directly to the developers, I decided to spike on developing a bunch of high signal regular expressions. And you can see there's a list here, but this is a list that's grown over time, and it's still a lot smaller than I want it to ultimately be, but I've been very strict into only allowing regular expressions that only will flag for pretty high confidence reasons. The pros are pretty much what I described before. It reduces the noise a lot. It's also customizable. So I've got a flag that allows you to give it an additional set of regular expressions for new rules, and you can remove the old rules and replace them with ones that make more sense for your environment. So if you're running in Azure, remove the AWS rule and replace it with an Azure rule. They can also be used to identify low entropy secrets. So if you're pretty confident about a certain string that will always match with a password, then you can include that regular expression, and while TruffleHog's entropy detection will fall short, this will be able to identify it. So it scales a lot better. The cons are that this will miss out on the types of secrets that you don't know about. So when I run TruffleHog with the entropy mode on, it always identifies secrets to weird services that I've never heard of. And I haven't been able to enumerate every single regular expression for every single secret out there. So you miss out on some of that. And another downside is it still requires a little bit of manual triage, because even though it's accurately flagged a secret, you don't know whether or not it's live. You don't know whether or not it's maybe a test private key, which is more often than that's a pretty common thing is what I've found. So there's still some manual triage that's less than ideal. So this is kind of the model for how I've integrated this into a DevOps pipeline in the past. You have some commit hook that fires a TruffleHog scan. TruffleHog will run on that commit hook with your customized regular expressions. That'll then get sent to a triage system. We'll have to go through and identify whether or not the key is live or not. And then that triage step will ultimately go to a remediation step. And the remediation step isn't always straightforward, because you not only have to remove the secret, but you have to rotate it, and you have to do it without taking down a service in production, which can be a pain because sometimes you don't know where these keys belong to. So these are kind of the different steps, and that second step there, TruffleHog, is the one that I've open sourced so far. But if you remember back in the beginning, I talked about a bunch of different places that source code lives. It doesn't just live in Git. And so what about all those other places? There was a talk earlier today about finding secrets in Android apps, and they exist in every single place you can imagine source code existing, I promise. And so recently, I've spiked on package managers. So the two that I've been looking at are NPM and pypi, and similar to Git, they also have a revision history. So you can push a package to node in NPM and give it a version, and then you can push a new version, and then you can push a new version. And so if you accidentally push a secret in one of the old versions, you can bury over the top of it. And if you looked at the latest version, you'd never know. And in addition to that, when you push these packages to NPM and pypi, they don't pull from Git. They pull from the file system. So if you're tracking your work in Git, and you've got some sort of test script that you haven't staged or committed, there's a good chance that it'll end up accidentally packaged into NPM or pypi, even though it never made it to Git. So if you remember back to what I said about open source software reviews, again, there's a good chance that your security engineer is only going to look at the version control in Git. They're not going to pull down the package and read the source code that was published to the package manager. So that source code, by and large, goes unreviewed, even though there can be differences. So I went ahead and scanned a whole bunch of packages and tried to see if these problems were systemic. And what I found was if your package on NPM or Git had the string AWS anywhere in the description, there was about a 2% chance of that package having a live AWS token in it. And what's worse is, in most cases, that AWS token didn't show up in Git. So it was in the package in either a testing script or in an environment variable script that was designed to be sourced from. And that just got packaged up and sent to NPM or pypi, and it never made it to Git. And then the last bullet point here is maybe experimental code where the developer knew that they were just temporarily inlining a secret or a password, but they would never actually commit that to Git. And their intention was to at some point pull that out and make it an environment variable. But when they packaged NPM and pypi, they weren't paying attention to the fact it was just pulling all the files in the file system, and that experimental code accidentally got shipped. So I made a new tool, and I'm calling it TruffleHog, which is a really dumb name. But I'm excited about it because I really want to see the sketch artist draw a Santa hog. My original thinking is it's like a package that you open and you get secrets, so it's Santa, and then hog is just for consistency, but other than that, it's the best I could come up with. So basically, currently, TruffleHog scans NPM and pypi packages. It goes all the way back through all the old revisions of the package, and it runs the same exact engine that TruffleHog does. So it runs the same regexes, and it does the same entropy detection that you could turn on and off. It's also open source, and it's available on my GitHub. I made it public last night, so you can visit my GitHub and use it. But this is the tool that I use to enumerate all those AWS tokens, which I reported, but my suspicion is if you look for different keywords, you will find lots more tokens live in NPM and pypi. And in addition to that, if you run internal mirrors of NPM and pypi, there's a good chance, maybe a higher likelihood chance, that those will also have live secrets. So this is an example of the output. It's not quite as pretty as TruffleHog currently, but here I'm scanning a package called tchannel, which is one of Uber's open source packages, and you'll see it flagged on a bunch of stuff. It flagged on an AWS key, it flagged on some private keys, and if we look at it a little bit closer, we see something interesting. These keys didn't show up in the code that Uber wrote. It actually showed up in a directory that Uber didn't mean to publish, the node modules directory. And if you're familiar with Node, basically the node modules directory is where all the dependencies for the package that you're using live. And so what they accidentally did here was they accidentally published their package with all of the dependencies and the dependencies and all the tree subdependencies of the project that they were working on. So you see several layers of node modules there, and we end up with AWS keys from packages that were never written by Uber, that Uber didn't know about in any capacity, but Uber accidentally published because they published all these other packages with their code. And this is interesting, and we'll come back to why it's interesting later and why it can cause some problems. So this is the revised DevOps pipeline. Basically, you have hooks for when a new package is deployed and for when you have git commit hooks, and they feed into the same triager, and the remediation stage is the same. So I could use some community help on this project. It's been just me and random contributors that I don't know committing to it for the last year and a half, but there's a lot of features that I could use. For starters, I need a lot more regular expressions. There's a lot of secrets that I'm not looking for, and they need to be high signal so that I don't make it really noisy. It would be really nice if you could specify a range of commits. Currently, you can specify a commit where you say to TruffleHog, scan from this commit onward, but the limitations are it will, number one, clone the entire package. It would be nice if it only cloned the relevant sections. And number two, you can't specify a range, so you can only specify from this commit onward. Another thing that would be really nice is multi-threading. Currently, it's single-threaded, so when I run it, I usually just spin up a bunch of instances of TruffleHog, but it would be nice if I could just specify via command line argument how many threads that I want. And there's a lot more features as well that I'm sure you all can come up with and offer to me, and I'm glad to accept pull requests. I am a little bit slow because I'm managing a bunch of different pull requests, but if the feature is small and well-contained and really easy to understand, I'm happy to merge it in. And then the last thing that I did in this past week, because SantaHog was relying on TruffleHog's regular expressions, I pulled the regular expressions out of the main TruffleHog project, and I put them in their own repository, and I pulled them out of a Python file, and I made them a JSON file, so that they can be used for other projects as well. So there's another project called GitLeaks that was basically a feature parody of TruffleHog someone made, written in Go. And when I looked at his source code, he had copy-pasted all my regular expressions over. My hope is that by pulling these out and making them their own JSON files, you all can pull these JSON files down and point to this reference, so that way we can have one community repository where we all update and keep these rules in one place. So that was kind of my thinking for pulling that out. And there's one more thing that I want to touch on here, that triage step on the graph. I mentioned that in a lot of cases it has to be manual, but in some cases it can be automated. Specifically, when you're authoring to public APIs, if you've got a live key, you can use that key on the public API and very easily tell whether or not it's live automatically without a human having to do the verification. And I have one simple example of that here. This is a simple Python function I wrote that takes an AWS key and returns true if the key is live and false if the key is false. So you can imagine taking the output of TruffleHog, sending it directly to these verifiers, and then based on the result of the verifier, automatically knowing whether or not you need to take remediation steps. There are some drawbacks to doing this, and this kind of brings me back to the T-channel example. Let me start by saying I'm not a lawyer, and this is not legal or financial advice, but you should be careful with the Computer Fraud and Abuse Act. If you are scanning everything, more likely than not, you will end up testing keys that accidentally got packaged into your source code that don't belong to you, because you're pulling in dependencies, you're pulling in code that was copy-pasted, and if you authorize to a system with those keys, you're probably violating the CFAA. You're authenticating to a system that you didn't get permission to, or in a way that you didn't have permission. And you probably should not use these auto verifiers for bug bounties either, for the same reason, for actually more so the same reason, because a lot of times bug bounties will not allow you to authorize with credentials that you've extracted. So if you find a credential, usually bug bounties say stop testing and don't actually auth with them. So if you do write these auto verifiers, be very careful with them and the way you use them, because you may end up accidentally winding up in some legal trouble. These are all the resources. So TruffleHog, SantaHog, and the regexes are all available on my GitHub, and feel free to check them out and to use them for your own personal projects. That's sort of the end of my slide deck, but I do want to open it up for questions and community engagement in case anyone has any ideas for the future of the project. Yep.
For your triage pipeline, what does that normally look like inside, and what's your ideal way of presenting that to your security or DevOps team and having them evaluate the findings?
So the question was, what does the triage process usually look like in your DevOps pipeline? And for me, ideally, in a perfect world, you'd be able to give these directly to the developers, give the results directly to developers. Now, realistically, even with my high signal regular expressions, sometimes you're also going to have false positives, and sometimes you're going to have keys that aren't live anymore. So for those cases, if you build out automatic triagers, you can use that to identify which keys are live, and 100% of the time, you can deliver that result directly to the developer because you know there's a problem. For the cases where you can't build out automatic triagers, it's a little different. If you try to give that to developers, you may end up with too much noise. And if that's the case, you'll have to manually go through and refine the TruffleHog rules a little bit. But obviously, the other side of that is if you're a small enough company or a large enough security team, you may be able to have some of your DevOps or your security resources to help with triage. Yep.
And then would you deliver those to developers over Slack or as a comment on a pull request? Or how would you present that?
Yeah, so you do have to be really careful with the secrets for obvious reasons. You don't want to propagate them in more places. The way I've handled that in the past is if you're using GitHub, just construct a URL that has the line number and the commit hash that just directly links to the problem, but don't actually take the secret and replicate the secret. Don't store the secret in a database because then you're just creating a centralized repository where all the secrets live. And in a sense, you still have that with the URLs, but at least you're not actually copying the password and putting it in more places. Question over here.
Have you thought about operationalizing the removal of the history in this tool?
Yeah, so there is a really good tool for cleaning up the history. The problem is you don't want to accidentally take down production services. So that one can be really tricky, and usually it's going to require a lot of human intervention to figure out what that key is, where it's being used. And if you try to just automatically pull it out of source code or auto-rotate the key, you may end up in trouble. But I think your question was more towards after you've already identified the problem and rotated the key, how you remove it from source code. There is a good tool for that. I don't remember the name, but it's a good point. I'll try to provide a link after or something like that. I think Ben had a question, and then.
What do you think of Santa Hog?
Oh, that's pretty good. I like Santa Hog. Yep.
Have you encountered any situations where regular expressions are kind of difficult to get the pattern you want, and if you considered maybe like some custom code processing or anything like that?
Yeah, so the question was, are there ever any situations where getting the regex just right is really difficult, and you maybe need to design some kind of custom code to maybe increase confidence? And I have thought about that a lot. I know the tool that Lyft open sourced has a confidence rating of if it meets this, then add 1 point. If it meets this, then add 1 point. And if it exceeds a threshold, then report on it. But I really wanted to design TruffleHog in such a way that you can confidently take on arbitrary rules from arbitrary sources and not too much worry about the threat of arbitrary code being executed in such a sensitive secret capacity. And so for that reason, I've kind of strayed away from allowing arbitrary code to help identify these secrets. There's a question back there. Yes, I think that's the one I was thinking of. So BFG repo cleaner is the one that makes it really easy to scrub the secret out of your version control. So it would be interesting to chain the two projects together and have them sort of automatically work together in some way. That's a good point. Yes?
What about non-source repos, sort of like OS images repos like Docker Hub or MI?
Totally. Or like apt-get or like RPM. Yeah, it's a problem. I can guarantee it. I haven't written the code for it, but I promise you, if you can think of a package manager, it's got secrets in it. I accept pull requests. Yep.
How do you differentiate because I know a lot of URLs have sort of like semi-random, almost like keys in the URLs to like identify specific resources, but they aren't necessarily secrets. So do you have a function for those, and how do you focus on like manual?
Yeah, so this is going to be the last question because I was given the timeout. Basically, That is a problem. URLs often have hashes in them, and that can be a problem. I've tried to make the regular expressions in such a way that either the secret has to be wrapped in quotes, which is pretty uncommon for URLs, or you expect the name of the service and then the secret length to try to cut down on noise. But sometimes, even with all that, you sometimes still get that problem. And I think it can be solved with a little bit smarter regular expressions, but I've done my best to try to cut down on that as much as I can. That was a good point, though. All right, I think I'm out of time. Thanks, everyone.